This is Brian Oltrogge from Groomblaw Design Studio. In this tutorial for Grasshopper, I'm going to start with a very simple definition of a box with an X and a plus in it. This way, we'll sort of be able to see what is going on in Grasshopper and familiarize ourselves with the way that Grasshopper wants us to communicate with it. So in this tutorial, we'll be drawing a simple box that looks like this. Pretty simple, right? But what I want this is to be able to be parametric, so I can change the height or the width of it and have all of these relationships remain in the definition. This is a very simple definition, and we'll be adding layers of complexity to the concept to sort of arrive at a much more complicated definition of 3D trusses generated on a NURB surface. So let's get started. This is what I'm shooting for in Grasshopper. So I already have the Grasshopper plugin installed. If you don't, it's a free plugin that you can download and install at any time. Since mine's installed, I just call it up by typing in Grasshopper. So when you open Grasshopper, this is what you'll see. This is sort of a canvas, and it's a node type engine. So all of these will represent nodes that you can plug information into. There's also a search box. Generally, probably 80% of the time I use the search box instead of using these items up here. But if you're ever stuck, you can sort of think about what you're trying to accomplish. Are you trying to draw a curve, for example? Then you might go into the curve toolbar. But this will become pretty straightforward as we get into it and start using it. So here is what we're trying to create. I'll just move that over here. And to begin with, you notice that I inputted an initial point. So I could do that in Rhino and reference that in. That's what these icons with a hexagon around them. These are for referencing geometry that already exists in Rhino. They're also useful for other things, but primarily that's their function. But I want this definition to be completely within Grasshopper, so I'm going to need to construct a point that exists in Rhino that is placed there by Grasshopper. So to get started, I'm just going to double click and start typing construct a point. And here's construct a point. So you can see here's a node, and in this node I have a value for X, a value for Y, and a value for Z, right? That's the definition of a point. By default, it is 0, 0, and 0, which of course is the origin. And you can see that Grasshopper has placed a little object at the origin, a little X. So we now have our point. And if you noticed when I drew this, I went from point here to point here to point here to point here, and then back to the beginning. So I'm going to do the same thing for this Grasshopper definition. So I'm going to move, because you won't find copy in Grasshopper. It's just you're creating geometry, then you're doing something to that geometry. So I'm going to take this initial point and move it. Right? So nothing happened because I don't have the translation vector. Remember, a vector is distance and direction. So I'm going to have to establish a direction. And the direction is going to be in X. So let's just start typing X and see what comes up. Oh, there's unit X. That seems appropriate. So I'm going to go a move in the X direction. So I plug that in. Now remember, information always travels through these nodes starting on this side and coming out this side. So by default, I have a dimension of 1. So it gave me 1 to say, all right, I kind of understand that. But I want to actually define what that dimension is. So before I was doing 10. So in order to do a slider, you can just type in a value that you want and hit enter. You can plug that into there. Now you can see that that moved 10 over. So I have this point and this point, Now I need to come up here and draw this point. So I can also move this one that I just created up here in the Y direction up here. So I'm going to need another move. And I'm going to start organizing these so that here is sort of an abstraction of what I'm looking for here. So I'm going to take this geometry. Notice when I have it highlighted, it's green. I'm going to put that up here. But this time it's a move in the Y direction. So I'm going to type in Y, unit Y, and I'm just going to go ahead and use this same factor for the dimension. So now you can see that I have this point, this point, this point, and I need this point. That's going to be yet another move. So I'm going to do move, and it's this geometry. This is a unit X, right? So I'm going to type in X. And just to show you that we're going to have to do one more step, I'm going to plug that in, and you can see that this headed in this direction, which of course is positive X. So we need to change that to a negative somehow. So I'm just going to double click and type in negative. Now I have a node that anything that I put in this side comes out this side negative. So make some space for it. So 10 becomes negative 10, and when I plug that in, it goes back to here. So now we have the 4 points of the rectangle, or the square in this case. I need to use these points to draw a line all the way around these. And I'm going to need 4 lines. So let's start by typing line. And I'm going to want this one, which is create a line between 2 points. And I said I needed 4 of them, so I'm going to just go Control C and Control V so that I have 4. Go ahead and move this down, select these, and you can use Mr. Sparkle to align these for you. Keep everything neat. Okay, so we want a line between this point and this point. So I'm going to go from this point to this point. And I need a line from this one to this one. So I'm going to take this point to this point. I need another line from this point to this point. So I'm going to go from there to there. And then I need one going back to the beginning. So from there to there. Okay, so now we have our box. Now we just need to figure out how to draw these lines in there. So the easiest way to do that for this would be to divide each one of these lines in 2. So then we find the midpoint of these. So I'm going to go ahead and divide that. So divide, and we'd want to divide curve because that's what we're doing. So divide curve. What curves do we want to divide? Now we can add things to a single node by holding down Shift. Notice by my cursor I have a little plus mark. So I'm adding all of those in there. And you can see that by default, if I hover over N, I have a number of 10. So I actually want a number of 2. And I could just right click on this and set the integer to be 2. But I'd like to sometimes keep everything so I can see exactly what's going on. So I'll use a panel. If you didn't see where I got that, it's from here. Double click on that and just hit 2. Don't hit enter, just hit 2. And I'll go ahead and resize this to a little tag just so I know what's going on in here. Otherwise it would be hidden. Okay, so now I have these all divided by 2. So I got my new point in the center. But what I don't necessarily see is that there's 2 points stacked here. So there's the beginning and the end. So the beginning of this line and the end of this line are stacked right here. I just have to keep that in mind as I move forward. Okay, so in order to draw lines from this point to this point, because right now all of these points are in one container. So I need to be able to have them sort of separated so that I can then establish a relationship from this side to this side. So I need to cull, and I'm going to use Cull Pattern. So this will take a list of information, and based on a pattern of true or false, it will throw out some items and keep the other items. So I'm going to plug this into there, and there's already a pattern in here, but it's not the one that we need. We need to figure out what pattern we do need. So I'm going to concentrate first on separating these out into the 4 corner points and the 4 midpoints. So let's do the 4 corner points first. Now remember, I said that there was 2 right here. So I want to establish a pattern that will delete some and keep some. So let's say I start with true to keep that one. I don't want this one, so false. So true, false. If I throw away the first one that's stacked here and keep the next one, that would be true, false, false, true, false, false, true. Notice a pattern here? So that is the pattern that we'll set as the Boolean pattern. So I'm going to right click on here and do Manage Boolean Collection. Okay, so I had said true, false, false. I don't need this one. So I'm going to hit OK and select this, and you can see that the corner points now light up green. Okay, I need one more cull containers for these midpoints. So I'm just going to go ahead and Control C, V, and so we want to go false. I don't want that one. True, false, false, true, false, false, true, false. So that's our pattern. False, true, false. So false, true, false. Hit OK. Now you can see that we have the midpoints. So now what I need to do is separate these. So if you imagine, if I go to this one, and I'm going to use the display options that are up here. So many times I'll click on this one. What this does is it will only show you the geometry if it's selected. So if I have that on, it'll only show me what is in the nodes that I select. So if I look at this one and I want to create these lines that go from here, imagine these are 2 people standing on a cliff across from 2 other people, and they're going to throw a rope across. So we need these 2 on a cliff and these 2 on a cliff. So I could do that by culling, but I'll show you a list item instead. So what that does is allow you to select items from a list. So I'm going to do list item right here. So I'm going to put this list in there, and which item do I want to select from the list? I don't know yet, because I don't know necessarily which item number these are. So if I look at what's going on in here, I have 4 items on a list, and I actually have a little bit too much structure here. I just want 4 simple items. So I'm going to go ahead and flatten both of these lists. So now it's just a simple list of these points. So I could look at these and sort of tell where they are. This is the point that's at 0, 0, 0. But in order to make it easier on myself, I'm going to go ahead and use a label. So I'm going to go to Display and click on this one, which is just a point list. So if I plug that into there and add another one, those are kind of small, so I'm going to go ahead and right click on this and change this to a 1. That way that they're a little bit bigger and we can see it. So now just paying attention to this top, or the corner points one, I have 0, 1, 2, and 3. So I want to put 2 and 3, or 3 and 2 in a container, and 0 and 1 in a container. So using this, I'm going to right click on I, set multiple integers. I'm going to type in 3, enter, 2. So now you can see that those two items are in this container. So let's do another one for 0 and 1. So I'm going to right click on this, set multiple integers, 0, enter, 1. So now I have those 2 points in a container. So now all that's left to do is to throw the rope. So I'm going to type in line between 2 points. I'm going to plug this item in and this item. Now you can see that I've thrown ropes, but they threw them to the wrong points across the way. I actually wanted them to cross. So that means that I can either switch this from saying 3 and 2 to saying 2 and 3, or I could simply right click on this and reverse one side. So there is my X. Now we're essentially going to do the exact same thing for the other side. So I'm going to just Control C, V, that, and I'm going to plug our plus mark side into that. So there's our plus mark. So if I take these and these lines, you can see that we've created that exactly, but the benefit now is that it's parametric. So I can change this and it changes the size. Now if I wanted this to become a rectangle but still have this same relationship, I just need another slider. So let's say another slider, and instead of doing 10 for X and Y, I'm going to do this slider for Y. And I just select this so that we can see it. Or I can just toggle off this view. Now you can see that when I change that, it changes only the X and Y, but all of these relationships that we established through this definition are still preserved in this model. So now let's take this simple concept and turn it into a truss. I'm going to go ahead and select all of this, use my middle mouse button and hide that, because I'm just going to start a new definition. So to begin with, I'm going to construct a point like we did before. So construct a point, and I'm going to move that point out to be the bottom of the truss. So go ahead and get rid of this for now. So move in the X direction. So unit X. And how far do I want to move that? Let's say about 250. Okay, so we're moving that point. I'm going to have to zoom out to find it. There's our other point. And between that, I'm going to create a line. So a line between 2 points. So from the first point to where we move the point, now you can see that we have a line. And now I'm going to move that line up. I could offset it, but I'll just move it for now. Move. So moving this line, this time in unit Y. And the depth of the truss, let's call it 25. So now we have line for the upper part of the truss. Okay, so now we're going to be dividing this like we did the sides, because we're going to be drawing these lines in here that resemble a truss. So how do I define what that interval will be? I want it to maintain a square relationship for each of these truss members. So I'm going to take the length of this line and divide it by this height. That would give me the number of divisions are on this specific line in order to maintain what would be a square relationship. So I need to first measure the length of this line. So I'm going to type in length, measure the length of a curve. So I'm going to measure this line, and that will give me the length, which is 250 because we defined that. And I'm going to do simple division, which is division. So I'm going to take the length of this line and I'm going to divide it by the height of the truss. And that will give us 10. And I'm going to use that number to divide these curves. So I'm going to do divide curve. Move these up. And this is saying, what curve do you want me to divide? Well, that one. How many times do you want me to divide it? 10. Or whatever that number is generated. And that will output our divisions along the curve. And I'll need to do that for the top too. So I'm just going to Control C, V. I want the bottom of the truss to be down here and the top of the truss to be here. So this one I just need to replace which curve it's dividing. So I added the length of this, so it's going to measure the length of this one, which just happens to be the exact same as this one, and dividing that by 10. So remember how we got rid of ones that we don't want. So along here, if I imagine a truss member, it goes up here, down here, up here, down here. So I'm skipping this one and this one. So I'm going to want to do true, false, Cull pattern to get rid of some of these extra points because we're going to be drawing lines in there. So I'm going to do Cull pattern, and I said that I wanted it to be true, then false, and I don't need these ones. Okay. So now you can see that actually this one I want to be down here because we're going to start down here, go up here, down here. So this one I want to be false, true. So I'm going to change my booleans on this one and just flip those over. Okay. So now I'm going to turn on my green cylinder again. I have those ones and I have those ones. So we have enough to draw the verticals. So let's go ahead and do a line between 2 points. And the verticals are going to be between those lines and those lines. So from those points to those points. Now I have those vertical lines, and we'll begin to draw the lines for the angular members. Okay, so in this list, I have this number of entities. So I have 1, 2, 3, 4, 5, 6, or I could just hover over here, it says 6, and over here I have 5. So the upper ones have 5. That means if I'm going to draw curves in between these, or lines, I need to make sure that they're both 5 and 5. Otherwise, I'll have an extra one that Grasshopper isn't going to know what to do with. Just to show you what that looks like, I'll do line and simply plug these in as they are. Now you can see that I have all of these lines that I want, but I don't want this one yet. I'm going to draw that with the lines that go this direction. So I want to get rid of this extra one. I'm going to do that by doing shortest list. So if I go to sets, here's shortest list, or I could type in shortest list, whichever is easier. And so I'm going to compare these two lists, and it's going to trim the end. So I'm going to put that list and that list in, and then if I hover over here, now I have 5 in there and I have 5 in there. So I'm going to try our line again and just plug this directly in here. There's my lines. But now I need the lines going in the opposite direction. So I'm going to have to shift these points one in order for it to start drawing from here. So I want to shift one set of these points in order to have the correct structure. So I'm going to do shift list. Since we're dealing with a list of 5 items, if I shift them down, I can either have the one that was at the end of the list come back up to the top, or I can have it just drop off the list. In this case, I want it to drop off the list. So I'm going to plug in this group of points that we had. I'm going to shift the list by 1, and whether I want it to wrap to the top or not, that's another boolean. So in this case, I want the boolean to be set to false. So I'm going to right click to here, set boolean false, and now I'm going to create another line. And that goes between this one and this shifted list. Oh, actually this is the one that has 5 in it, this is the one that has 6, so I'm just going to reverse that. And there's our lines going the other direction. So now we have our angular members and our vertical members, and we should still have our bottom and top. So there's our simple truss that we can then change. So when I change these, it changes the truss. So now I'm going to use this definition to sort of make it even more complex. So we have this simple 2D truss drawn out. I'm going to take this definition and apply it to a surface that's going to populate multiple trusses. So now that we have this definition, I'm going to take out of it these items. So this was just defining the 2 lines in space. So I'm going to use Grasshopper to define that in a different way. So I need only these items here, and that's what's going to become part of the definition for the more complicated one. So I'm going to Control C, V, bring that down here, and I'm going to go ahead and disconnect all of these. So now we just have this definition, and I can hide this thing that we did before. So I'm going to hide that. And since I'm going to apply it to surface, I'm going to need a surface in Rhino. So let me quickly draw a surface in Rhino. So let's make it 40 feet by 120 feet. And I'm going to rebuild this so that it's not just a flat plane. So let me go ahead and rotate this out, rebuild, okay, and I'm going to move up, say, these points, just so it's a little bit more interesting than a flat plane. Okay, so this is the surface that we're going to be working with. And remember, I said that these are the containers that Grasshopper uses for referencing geometry that's already in Rhino. So I need the surface container, and so I'll right click on that, set one surface. Now if I select this, you can see that Rhino knows that it's there and that this surface is green. Just so I can make easy changes to this surface, the first thing I'm going to do is move the referenced surface off of this. So I'm going to do move, and I'm going to move it this way, so Y, unit Y, and maybe 1,000 inches. There's my reference surface. So for now, I'll go ahead and just hide this so we can concentrate on this. Okay, so to start with, I'm going to need a bunch of lines because that's what we were using to define this geometry up here. It was a single line that we then offset or move away from the first one to become either the top of the truss or the bottom of the truss. So I'm going to need to run a contour command on this. That will slice this up like a loaf of bread. So I'm just going to type in contour. I'm going to use contour or create a set of brep or mesh contours. That way I'll know what questions I need to answer. So brep or mesh to contour, that's this one. Point, so this is the starting point for the slices. So I need to define a point. If I was working in Rhino, I would just click on this endpoint. So how do we get that endpoint? Well, just like we could deconstruct a point, or to construct a point, we can deconstruct things as well. So I'm going to deconstruct the brep, which this surface is a brep. And when I deconstruct a brep, that gives me the faces, the edges, and the vertices. So this is one of the vertices. So let's use our list item and plug in the vertices. So now I have a list of those 4 vertices. Which item do I want? 0, which is the very first item on the list. And if I click that and the surface, and this surface, you can see that that is the point that I wanted. So I'm going to go ahead and plug that into point. N is direction. So I want it to go in this direction, and that is the X direction. So X, unit X, so we're contouring in the X direction. I just plug that in. And the distance. So this is the distance between the slices. So let's go ahead and make another slider at 48. And I'll plug that into the distance. Now you can see that we have our contours on that surface. Okay, so the next step is to go ahead and offset these contours so that right now we have the top of the truss, and I want these all to offset down so that we then have the bottom member of the truss. So go ahead and clean these up a little bit and type in offset. So what curve do I want to offset? I want to offset these contours. So offset, distance, let's do it the same as the spacing. Well, let's do another one. I'll just type in 48. So this will be the depth of the truss. Plane, well, let's see if we need it. Yep, we do. So some of them, if I add this, some of them offset up and some of them offset down. We want to make sure they all go in the same direction, so we'll have to define the plane that they offset on. So that plane is the Z and Y plane. So I'm going to type in ZY, or maybe YZ plane. Plug that into P, and now they should go all in the correct direction. So now we have the upper and the lower curves. So here is our upper curve. Here is our lower curve. Now I just need to plug them in. So before we were measuring the length of the curve and then dividing by the depth of the truss. And this is the curve that we're dividing. Same thing with down here. So this is the curve that we're measuring. This is the height of the truss. And this is the curve that we're going to divide. Now you can see all of those turned just like before. And if I select these, you can see that the definition still applies. So I can change the distance between the trusses, but I can also change the height of the trusses. And if I hold down this, you can see that there's our trusses in space, at least a 2D representation of them. So let's make them 3D. Simple way to do that would be to do the pipe command, which is just going to create a pipe around all of those curves. So I'm going to turn that on so we can see everything. And I'm going to do a different radius for the top and the bottom members from the interior members. So I'll do another pipe. And let's make a slider for the diameters. So for the upper and lower, I'll do, let's say, a 3-inch radius. So I'll plug that in there. For the end style, I'll right click on that and make them round. So I'll make these ones round as well. For this radius, I'll do 1.5. And I can pull this one up here. Just kind of moving it around so everything makes sense. So if I select these are all the ones that are the inside ones. And remember I said that there would be maybe another use for a curve container. If I do a curve container for the top, maybe a curve container for the bottom. That way everything's down at this end and easy to select. So I'll plug in the top and bottoms into the 3-inch radius. Hold down Shift. And for these ones, I'll add those to the 1.5 inches. So turn back those and the surface. So there's our trusses on a surface. Now remember we moved this here so that if I unhide this surface, this is the reference surface. So any changes that I would make to this will be reflected over here. So you can see how that's automatically updating. And once again, all of those are parametric. So I can change the spacing in between the trusses, and I can also change the height of the trusses. And so now if I wanted to go ahead and bake this into my Rhino environment, I would select the pipes, maybe the surface, click on Bake. Go to Edit, select Last Created Objects, move these off. And there's my set of surfaces. Or my trusses on my surface.